All right, so now that we know what sine and cosine and tangent are, we're going to move into what we actually use them for, which is solving for missing sides in a triangle. But before we get there, we're going to practice plugging these into our calculator. So first and foremost, we have to make sure we're in the right mode in our calculator. So if you look on your calculator right next to the blue button, there's this button called mode. So if you go to the mode button, you're going to come up with all of these here. Now, if you notice on mine right now, this black little rectangular box is over the word radian. I don't want it to be radian, I want it to be degree. If we don't change it to degree, we're going to get the completely wrong answer. If you have it in radian mode and not degree mode, you're going to get the wrong answer. So in order to change it, what we're going to do is we're going to go down and see how it's flashing on radian. We're going to go over so that it's flashing on the word degree. And then if you press enter, now you're in degree mode. Now the black rectangle is over the word degree and not radian. Okay, if you don't do that, you're going to get all the wrong answers on the test and you're going to be really mad that you got them wrong. Okay, so always double check that. So on the first example here, it wants us to type in sine. So if you look here, we have sine, cosine, and tangent. So I'm going to press sine. We're going to type in 32 and we're going to close the parenthesis. And that gives us 0.5299. So the 9, well, it says 4 decimal places, I guess. So I guess we don't have to round. So 0.5299. Now if we do cosine, so cosine is here of, what was it, 54. Close the parenthesis. That gives us 0.5878. We round, the 8 tells the 7 to round up. Sine of 30, 0.5. Okay, then tangent of 45 gives us 1. And then you can plug those two in. Okay, so now that we know how to use our calculator, let's get rolling with some math here. So in this first example, we want to find x. We want to find our missing term. So whenever we're doing this problem, the first thing we want to do is label the triangle. I'll put that over here so it won't take up too much room. So our first step is we're going to want to label the triangle. And what I mean by that is label it opposite, adjacent, and hypotenuse. Okay, so here's our angle, 25. The x is the opposite. Here's our right angle. So this is our hypotenuse, which makes the 18 the adjacent. So I always start by doing opposite, then I do hypotenuse, then I do adjacent. Maybe I'll write that in a different order to help you guys. So I start by labeling the opposite, then I label the hypotenuse, and then I label the adjacent. So opposite, hypotenuse, adjacent. So that's step 1. Step 2 is that we want to pick a trig. So meaning we want to pick, are we going to use sine or cosine or tangent? And the way we're going to pick that is by using our SOHCAHTOA. So if we look here, next to the O is the x, next to the A is the 18, but if you look, there's nothing next to the H. So we're actually not using the H here. Okay, so I like to cross it off. There's nothing next to the H. So that only leaves us with O and A. So if we use our SOHCAHTOA, which one has O and A? Well, tangent has O and A. So we are picking, in this case, tangent. So now that we've picked our trig function, we're going to set up the problem. Okay, so now that we've picked tangent, we're going to have tangent. And with our tangent is always parentheses. And in our parentheses is the degree. So in this case, it was 25 degrees. And then just like our SOHCAHTOA tells us, it tells us opposite goes on the top and adjacent goes on the bottom. So opposite is x and the adjacent is 18. Okay, so we've got our angle goes with the tangent, and then we have opposite over adjacent, so x over 18. Now I like to always put this over 1, and then look, it's super easy, we can cross multiply. X times 1 is x, and then we have 18 times tangent of 25. Well, now that x is all by itself, we can go ahead and plug it into our calculator. So we're going to go to our calculator. We're going to do 18 times tangent of 25 and then end your parenthesis. That gives us 8 point, says round to the 100th, which is 2 decimal places. So 8.39. Okay. Okay, so let's follow our steps. Step 1 is to label our triangle opposite, hypotenuse, and adjacent. So here's our angle. This is our opposite. Hypotenuse is across from the right angle. And then adjacent is whatever one's left. So step 1 done. Step 2, pick a trig function. So I need to pick sine, cosine, or tangent. Well, in this case, there's nothing next to the O. So I'm going to cross off the O. That just leaves us with A and H. So we're going to have A and H in our SOHCAHTOA. A and H goes with cosine. So cosine is what we picked. Now we're going to set up the problem. So we have cosine of parentheses, and I like to put that over 1, equals our other fraction. So our parentheses is always our degree. So 70 goes in our parentheses. And then our SOHCAHTOA tells us adjacent is on the top, adjacent is 15. Hypotenuse is on the bottom, so x. Now that we have it set up, I guess step 4 would be solve. I didn't write that down. So solve, cross multiply. 15 times 1 equals 15. And then we have x times cosine of 70. Now in this problem, when we cross multiplied, x is all by itself, so we went straight to plugging it into our calculator. But in this problem, we have x times cosine. So x is not by itself, so we need to keep solving. So if we want to undo multiplication, we use division. So I'm going to divide by cosine of 70. I can't just divide by cosine. I can't just divide by 70. These are attached. Pretend they're glued together. You can't unglue these. So those cancel, but whatever I do to one side, I have to do to the other. So I'm dividing by cosine of 70. So we go to our calculators. We do alpha y equals to give us our fraction. 15 divided by cosine of 70 gives us an x of 43.86. Okay, number 13 here, it tells us that our slope here is 5 degrees, so we have a triangle with 5 degrees. After traveling a horizontal distance of 100 feet along the part of the trail, what would be the change in the hiker's vertical position? What is the distance of the hiker along the path? So we want to find the vertical height that he's walked as well as the actual height, right? This is where he would be walking along the hill. So we went 100 feet if you're looking at it this way. But this is our hypotenuse, it's going to be a little bigger. So let's first start by solving for x. So our first step, remember, is label our triangle. So here's our degrees, 5 degrees. So x here would be the opposite. Y here would be our hypotenuse. And this 100 is thus the adjacent. So if I want to solve for x first, we don't want to use y. So we're going to cover up y. I don't want to solve x by using y. So I'm not going to use y. So if I'm not using y, that means I'm covering up the h. So O and A in our SOHCAHTOA, O and A goes with tangent. So we're going to use tangent of the angle, 5 degrees, over 1, equals the opposite, which is x, over the adjacent, which is 100. And we can cross multiply. So 100 times tangent of 5 gives us 8.75. Oops. Okay, now if we want to solve for y, same thing. I don't want to use x, so I'm going to cover up x here. So if x is covered up, we have a and h, which means we're using cosine. So cosine of the angle over 1 equals adjacent, which is 100, over hypotenuse, which is y. Now cross multiply. Y is not by itself, so to undo this multiplication, we'll use division. So 100 divided by cosine of 5 gives us a y answer of 100.38. Now those numbers should make sense if we think about it, right? Our hypotenuse should always be the biggest side. So if this is 100, then our hypotenuse has to be bigger than 100. However, it makes sense that it's not that much bigger than 100, right? Because this is only a 5-degree angle. If it was a bigger angle, then this side most likely would be a little bigger. And then it makes sense that this is so small because this is such a small angle as well.